Welcome. Now in this video I want to show you how to make a DDR3 memory stick. I know DDR3 is not like the newest thing anymore, not that relevant, but the same process or the same method should be applicable to DDR4 and 5 as well. My end game for this is to use cheap ECC server memory. Now they are, as is, they are not compatible with desktop computers or consumer hardware. They're built differently, but the chips are the same. So what we need to do is take a donor for the, from the consumer memory space. This is a box standard Kingston 2GB DDR3 memory stick, and there is some saving in this. Obviously, the server hardware is cheap, and it's cheap because it's not relevant in the professional field anymore. The machines that would use DDR3 are not energy efficient anymore. For this 4GB stick, and I bought this as a test, I paid more on shipping than I paid for the stick itself. The stick was like 1 Swiss franc, so €1, $1, whatever. So yeah, like nothing. This year I had this, but I looked it up. They are sell for like $4 a piece. And this project is actually quite cool if you want to start out with BGA repair stuff. As I said, they are very cheap, so if you make mistakes, if something doesn't work out properly, well, it's not that big of a deal. But there are quite a few techniques that you can learn from this, from doing this. There's also the software side, and we will need to make a flashing device using an Arduino for that. And so a bit of hex editing. So it's a broad project where you can learn quite a few techniques and stuff and see new stuff. So yeah, I would really recommend, if you want to get into that, that's a really cool way to start. But nevertheless, like the disclaimer, I'm not an expert, and I do this as always in the jankiest way possible. So I don't take any responsibility. Proceed with caution, but have fun, because it's actually quite a cool project. Quick intermission. Initially I wanted to do all in one go, so have the reballing part and the software part in the same video. But as the project progresses, I realized that it's way too much. So what I'm going to do is I do one part with the hardware, so with changing the chips, and one with the software. Another reason for that is that this FPD flashing device is actually also interesting to other people, so they can find it as well. You will find the video somewhere here for the flashing part, and I recommend that you do that beforehand, so that you flash your RAM stick as when it's in initial condition, and only after that change the chips out. As I pointed out earlier, we need 2 memory sticks. One of them contains the chips that you actually want. In this case, this might be this one. This is a buffered ECC memory. And the other one is desktop memory stick. In this case, it's a 2GB Kingston stick, and these are very plentiful. This one is from a old, like, lower end office pre-built thingy, so chances are that you have them kicking around anyways. If you don't have that, like, they sell here in Switzerland for like 5 Swiss francs a piece, something like that. No one really wants them anymore, so yeah, they can be had cheap. Prices for the ECC memory, for a 16GB stick, I would expect to pay something like 20 Swiss francs before shipping. And let's wrap up the prices. 2 8GB sticks of DDR3 memory, I would expect to pay like 40 Swiss francs, something around that. So it's a bit cheaper, but not a get rich quick scheme, something like that. So if you're after that, sorry, won't happen, because it's a lot of work, it's a lot of knowledge and experience that goes into it, and absolutely not worth it. But if you do it for a learning experience or for like doing stuff, well, that's a good idea to go for. Now in my case I didn't use this ECC memory because like this stick is 4 GB, so we can only use half of the chips on here, and since the receiving module only has 16 pads or slots available, this is like half the density of these chips, so we can only do like 2 GB sticks, and yeah, there's no point in that. I bought these for like reference only. But what I used is an old MacBook Pro motherboard that's dead, but it has soldered on memory 16 GB, so I can do like 2 8 GB sticks from that. Now if you go with old motherboards, you have to be a bit careful, since DDR3L, that's what I'm going to use, is compatible and will work, but not LPDDR3. So this LPDDR3 is like used in MacBook Airs, and that's a completely different technology. It works differently, different voltages and everything will not be compatible. DDR3L is fine, DDR3 is fine. Now another thing to look out for is like the BGA, or how the ball grid array is made up. You have basically to Google the chips that you are going to use, and you have to Google the chips that you have and the chips that you want to use, and then look up what footprint they have and if they match up. There are different footprints around, so that's something that you have to keep in mind when buying memory. And a last thing, like I had bit issues with, but I had to do quite a bit of searching. This memory here is Kingston branded, and Kingston does not manufacture memory, they just slap their names on here. And the way I found out which chips these are actually is some mainboard manufacturers have a qualified memory list thingy, and there the actual chip names are listed. So that might be a handy tip if you are in the same boat as I am. Now, apart from the memory, we also need some tools and supplies. And usually I wouldn't recommend like a cheapo hot air station, because they have not the greatest temperature regulation, also lacking a bit on the power department. But since these chips here, or the memory stick, or the PCB as a whole, is actually quite small, you can get away with a less powerful station. Now, another thing that you definitely will need is a soldering iron. Here I would basically take anything, just not one from the plumbing department that's made to solder a roof or something like that. Those won't work, but anything made for electronics, perfectly fine. The plumbing department stuff is also that applies to everything that I will say now, or from now on. Don't go shopping in the plumbing department. The flux is corrosive, or is made for a different cause or for a different kind of work, not suitable for electronics. That's really an important point that I want to make. Then next, microscope, it helps, but it's not strictly needed. If you don't have one, you can totally get away with magnifying glasses. There are these on a small stand for soldering stuff. Those will work. It's just a little bit more tedious, I guess. So as far as the tool goes, we're done. Now we need some supplies. One, you will need a stencil. These look like this. You can find these as a set on AliExpress or eBay. They are named a bit strangely usually, like DDR3, DDR2, DDR memory, reballing set, blah blah blah. I will link one maybe, or I show one. No, I won't link it, but I will show it. And yeah, the one thing that's really important is you have to get a set that says direct heat. So look out for that. Otherwise, the method I show from Reballing won't work. Also, these sets sometimes come with one of those holder thingies, and they are useful. You will need it, and if the set doesn't come with one, I would order one. Then another thing, you will need solder balls. Probably 0.45 millimeters, but make sure that you check that out with the stencil and the chip that you will need. Then some leaded solder wire. I have here like super old stuff. It doesn't really matter what brand or anything, just get whatever. Then some flux. Again, if you're starting out with this kind of stuff, brand doesn't matter. What I would recommend is that you get a like pasty flux with the syringes. That's useful brand-wise. Yeah. Don't pay like 20 or 30 US dollars or euro or whatever for one syringe. That's just too much, especially if you're just starting out. And then the usual stuff. Alcohol, I use denatured ethanol because it's cheap and it works. Isopropanol will also work, and some Q-tips. So, harvesting the chips. As I said earlier, I'm going to use memory chips from this MacBook Pro mainboard, and actually I already did it, lied to you. I harvested them here, and since this mainboard has quite a bit of thermal mass, I desoldered these chips 420 degrees C and 110 liters of airflow. Again, no nozzle on it because I want the broadest airflow that I can get. And this 110 liters is like 80% of my machine's capability. So if yours is a little bit less powerful, that's like the quick one. You can maybe up it to 100 or a little bit less, depends on your machine. Same with temperature. It's like, that's what I use and what works for me. That doesn't need to work for you, nor need my 420 degrees C be accurate. There is error in it, let's put it that way. If you start from a memory stick, you definitely want to use less power or like less airflow, also less temperature. So I'd say, I don't know, 80, 90 liters of airflow and 380, 370 degrees Celsius. Now with cleaning the chips, after desoldering the chips, these are actually cheating a little bit on camera here. These are the old chips that we won't use, the small ones. But nevertheless it's the same. We have to clean them first. So now what you want to do is put some flux on them. Then piece of desoldering braid and wick away all the old solder. Now it's quite important that you do this with a little bit of care, because so don't use force on any of this, because you can quite easily rip up the pads, and if you rip the pads, well, sometimes it can be saved, but usually it's done. Soldering iron wise, here it helps if you have a little bit of a bigger tip, not huge, but not like the very fine tips, and if you have some power on your station. Otherwise it takes longer. Maybe if your soldering iron is really underpowered, you can also help a little bit with hot air. Now that we have wicked away the old solder, we can clean it with a Q-tip, a little bit of alcohol, to remove all the old flux. So we can start with a somewhat clean chip. Doesn't need to be like perfect in a clinical way, but you want to work somewhat clean with reballing. And that's especially true with like dust and fibers. Dust from these Q-tips or fiber from these Q-tips, they can mess around with the solder balls, and yeah, you don't want that. So let's get to the meat of it, the reballing. Now again, clean stencil. Want to add a little bit of flux, not a huge amount, just a tiny bit. Then spread it thinly over the chip. So there is no point in using too much flux, but just a little bit that helps with sticking, that the balls stick in the stencil a bit, but also obviously to when we reflow it. Now put the chip roughly on the stencil and put it into the holder. Now here, when you put it into the holder, you want to have some wiggle room. Shouldn't be super tight, since when we heat it up, everything will expand a bit, and if it's super tight when it's cold, it might start to bulge, and that's not something that we want. Now we want to align it so that the whole when that is done, we can put it onto the tray and add solder balls, as I said, 0.45 millimeters. Now we can spread it with the finger a little bit. Remove some of the excess. And we have done that, we do the rest with the tweezers. Now that all the excess is removed, and there is one ball in every hole, put away the tray. And heat it up. I will use 380 degrees Celsius and 50 liters of airflow. And when you first start heating it up, the solder balls start out shiny, then they turn matte, and then they are shiny again when they're fully molten. And you want to go through these phases and fully melt them. And when they're molten, I will add a little bit of flux, heat it a little bit more, and after that we can see which balls are actually molten to the pad and which one are like dancing around freely. And if you spot such a ball, then just gently tap it with the tweezers so that it can melt to the pads. And I will use the nozzle on the hot air gun this time. So all the balls turn shiny now. I will add a little bit of flux. Just drag it over it. Tap the strugglers. And now we let it cool a little bit before we take it out of the holder. Now it's cooled down a little bit. We can remove it. Some balls we can remove too. Now you can see here and here there are grooves, and you can go under it with tweezers and slightly lift the chip. If it takes force, you shouldn't use force, rather use a little bit of heat to just liquefy the flux again if it's turned solid. But this time it was easy enough. Remove the stencil and we have a look at it. In this instance, all the balls are there, so we don't need to manually put some balls on it. In this case we would do it with the tweezers, put them on, heat it, and so on. Personally, I wouldn't do more like, say, 5 balls manually, because it's tedious and it's quite difficult because they tend to swim around and form big balls, and yeah, I would rather start off new if it's like more than 5 balls. But in this case it's perfectly fine, so we can reheat it so that all the balls are align themselves freely without being interfered with the stencil. Now they've done that, we can add another bit of flux. And we are done. Now, next we need to remove the old chips. If you use a silicon mat like me, you have to be a bit cautious because the silicon can, well, when it's heated up, it bubbles up, makes small hills, and that's enough to move these components around. So you have to be a bit careful. I would recommend that you buy a dedicated PCB holder, but if you haven't, you can get away with the stencil holder thingy. Just have to be a bit careful on the underside where you place the spring. Another thing, you might want to add some double-sided tape to the underside so it doesn't move around too much. Now, next thing is you need to make sure that you know the orientation of the chips. So every one of these chips has a small dots in one corner, and the new chips also have this dot and they must align. So I would really recommend that you make a picture of both sides so you know where each chip goes or how it's oriented. Also make sure that all of them are the same, so none of them like flipped from this side or this side, so they all match up how they should. Now, soldering wise, again, 380 degrees, 100 liters of airflow. When desoldering stuff like that, never use force. So only remove it after the chip moves freely. Yeah. So you don't want to actually rip it up. So it needs to fully melt beforehand. So let's start. I add some flux. And then heat up the PCB. Really make sure that all of it is melted beforehand. Now that the PCB had a bit time to cool down, so it's not, or all the other components are the solder already solidified and it's safe in place. we want to remove the old solder on the pads, and we do that first. We just go over it with a soldering iron, and after that I also add leaded new solder. Now you could remove all of the solder with solder wick, but it works without, and the danger with removing it with or wicking it is that you rip or that you damage the PCB. So if you're experienced, yeah, go ahead. If not, or you do not have a very powerful iron, I would recommend against it. Again, add flux where needed. Then take the iron and go over it. Until every pad is shiny from the leaded solder and it's evenly distributed. So you don't want to have like pads where it's a lot more than other pads. That might make, or that will be a bad thing when we solder new chips back on. But if it's even, it's okay. So, and we're done. Now what's left, we need to clean it a little bit, remove some of the dirt, and then we're ready to resolder the new chips in. I have cleaned it up a bit. You don't need to overdo it, but it's just so it's a little bit nicer to work with. We want to add a little bit of flux to the pads, but not too much, like a thin layer, but not drown it Rossmann style in flux, since otherwise it might really like float away. So just and you can do it all in the beginning, since if it blows away while we are soldering the new chips on, it doesn't really matter. So just make sure that some of it is there. Now it's the time to check your orientation. So you made a picture, I hope. And if you have, like me, you know that the dot comes here always for all the chips. So place it on and roughly align it. If you don't, like me, if you don't have any solder or silk screen to work with, it's either to check the old picture that it took or just eyeball it. It's a little bit off, it's not that bad. Just needs to roughly align. And now we're ready to heat it up. I use again 380 or 100 liters, I think. I don't know. Yeah, same as desoldering. So let's get started. So I don't know if you could see it, but the chip aligned itself. Now we keep heating it for a second or two, and this one is done. Next one up.
At this point, we are done from the hardware part. I assume that you already did flash the SPD. If you haven't, you will find a link to that in the description below. Otherwise, let's continue testing it out. So we put it into the PC and start it. And as you can see here, the PC boots perfectly and the BIOS detects all 16 gigabytes or both sticks of memory. But the real test will be if it's stable, if we can actually run this memory without any hiccups, without blue screens or any other unwanted stuff. And to test it out, I did run some hours of MemTest64 from Tech PowerUp, and it passed that without any issues, 0 errors, so that's pretty nice. I also did the Passmark memory benchmark, and as you can see here, they perform pretty similarly. And I'm actually not too interested in the absolute values, so if one or the other is point whatever percent faster or slower, but more does the new memory perform in the same ballpark? Is it too slow for what it should be? And that also shows here that it's actually performing just as it should. Now the real test for me is everyday usage, right? So I did that and I hadn't had no blue screens, no unexpected errors or anything of that sort. So that's a real win for me. And yeah, so I hope you enjoyed and see you next time.